Good morning and welcome to the second day of the EPFL CIS Digital Twin Days. Yesterday we had the opportunity to listen to fascinating talks from academia. Today we are looking forward to see great talks from industry and to conclude the day with a panel. Our first speaker today is Dr. Gunter Beitinger. He studied industrial engineering and business administration, and then after 5 years as a research collaborator at the University of Erlangen, he started his career in 1999 with Siemens and held since then various responsibilities in countries like Mexico and the US. In his current role as Senior Vice President for Manufacturing, he leads various digital lighthouse plants. He also is responsible for manufacturing excellence and the factory digitalization of all plants of the Siemens AG. Gunter, the floor is all yours.
Thank you very much for the introduction, Jan. I'm very happy to be with you today, and I hope I can bring you something interesting to this conference. As I am the first speaker, I try to make it as a wake-up with a lot of videos, so you also will have the possibility to know some of my team, which are speaking in the videos. So first of all, it is about Lean Digital Factory. Lean Digital Factory is a program we started 2016 in the digital industries, and then also now we are bringing it on the total Siemens AG. And I have the pleasure to accompany our factories on their digitalization journey. And what was the idea behind of it will be shown at this first video as a wake-up video, and it's about people and it's about collaboration. We at Siemens Digital Industries, we launched the program Lean Digital Factory to support our factories on the digitalization journey. Everything what we have reached so far was only possible due to our dedicated teams in more than 30 factories. For me, Lean Digital Factory is a role model of collaboration.
In unseren Werken nutzen wir das Digitalisierungsportfolio von Siemens. Gemeinsam mit der Entwicklung arbeiten wir daran, Funktionalitäten stetig zu verbessern, um das volle Potenzial von digitalen Zwillingen auszuschöpfen.
感谢 ELDF 建立了 SML 同西门子全球数字化和自动化专家的交流，从而实现了 SML 数字化和自动化水平的快速提升。
Nous partageons les mêmes objectifs décrits par des processus de référence et des feuilles de route définies en commun. De cette manière, nous trouvons les bonnes solutions pour la coordination de notre chaîne d'approvisionnement end-to-end basée sur l'intelligence artificielle et la transparence en temps réel.
LDF fosters new ways of working and our daily work in collaboration. Guided by our digitalization roadmap, LDF enables lifelong learning.
Flamingos are animals who rely on each other, they trust each other, they act as a team. We in LDF, we learn together, define our goals together, and we fly together, just like flamingos.
So now we have a little bit of an idea of our program. We have a mascot, that's the flamingo, as Frank said, is about flying together in the direction of digitalization. Thank you. Now I realized I have to stay here. So let's go into it a little bit. What is it about? What we have so reached so far? When we are talking about Lean Digital Factory, it's about, of course, joint projects. So this is the number of joint projects we are doing in our factory together. We are jointly developing and working together in our factories. We have common and upskilling programs. And of course, we are tracking how our people are adopting to this program by clicks on my Learning World, which is a learning platform we just established for the digitalization journey. And as Jan mentioned, of course, there was a lot of success since we started it. We have received various awards, and one of these is also the World Economic Forums. We have already 2 factories which are named as digital lighthouses, but of all, we have also won several other awards with that program. So the Lean Digital Factory for us provides benefits of our own products. It's for us important that we are using our own products. We as Siemens are providing as products, as software and hardware, which enables the factories to be more efficient, to be more flexible, to reduce time to market. And how we are going to do it is an approach that we first always start with proof of concepts. When we have identified a proof of concept in one factory and the factory takes over requirements from other factories, then we bring it into a pilot area and then we scale it up over all factories. And the portfolio, what we are using is just mentioned here below. And I come to this a little bit later, what this portfolio will enable in specific areas. So when we started it with about 30 factories. Now we are scaling it up to 180 factories. This is our footprint of the Siemens AG. And what we wanted, of course, is that we have challenges like any other factories out there. Our factories have to provide to the productivity, they have to be competitive, so shorten time to market, increase flexibility, improve quality, and boost efficiency. Is that what we are trying to reach and what we are always measured on? And of course, we have to deal with increased security, especially when we go to cloud, when you are connecting your factories to the cloud, then security is definitely a topic, and sustainability is also into our factories. We are aligning our goals with sustainability targets from the beginning. And here you have a little bit of an idea as we started in which factories we are implementing and supporting this program. So, but what was really the need for us? When we looked in our factories, we saw that there is a kind of well-established maturity in regards of lean projects. Lean projects are, for us, kind of a base productivity with ongoing continuous improvement projects. We were able to raise 3, 4, 5% productivity on shop floor. But as we became more and more mature, especially also with the introduction of simulation tools, upfront perfect and upfront good introduction of productions and production lines, there was difficult, and the number of shop floor programs increased dramatically to reach the 3 to 4% productivity. And also we thought that for competitiveness, we need to raise it anyway to 5 to 7% of productivity. And so we launched the digitalization journey, which should enable, and now it's also proven, it enabled our factories to raise up to 7%. And there's a little bit about it. So, of course, there's always classical productivity measures, the lean productions, and we put on it the flexible automation with the lightweight robots, with automation and with robotics, which before was difficult to attack due to economical reasons. But now with smaller robots, more economical robots, with these solutions we are finding, we are able also to automate contents which before were not economically feasible to automate. And then, of course, there on the top it goes digitalization. Meant here is more the vertical and the horizontal data integration. And then, of course, if you have this, you put on it big data and analytics and, of course, artificial intelligence to use the data generation and the preparation of the data to get more insights of your process. So that's a little bit of how we are approaching the topic over our factories. So this is now the general approach. It was not lined out up from the beginning, so it was more a kind of a sprint thinking. So when we started, of course, there was first of all ideation. We looked at it, what are the factories already doing? Because never we have launched a program which should cover all factories. But all our factories are more or less independent in the way they are working. We do not have homogeneous IT infrastructure. They are in different business units. The products are totally different. One are producing PLCs, the other are producing up to mobility parts for trains. So it's totally different from the way they work and also on which products they are working on. So we have a wide range of different products. So we were looking, what are our factories really are working on? What is important for them and what are their pain points? And this is why we did technology workshops and we looked also outside of inspiration, what technologies are important. So we did technology radars, which are nothing else that we clustered technology and we calculated how much improvement also economically can we reach by introducing this technology. And of course we looked what is the software, what is the IT infrastructure, what is the base, what we are having. But we never made a baselining because that takes too much time. So we just in general were looking which MES software are in our factories, which different shop floor is there, how they are connecting their machines to the next level if you think on an automatic pyramid. And from there, we derived the technologies we want to invest, and we also want to put experts together, and we clustered them in 5 working streams. We call them digital twin, processes, big data, analytics, autonomous manufacturing system, and new ways of working. But for orientation reasons and for lean thinking, we said, okay, what is the orientation? We have to give them a North Star, and the North Star is in our reference processes. A factory can be described more or less by 5 main processes, and then a lot of course, side processes are related to it. New production, introduction of new machines, introduction of new products, the order and scheduling process, the quality process, the maintenance process. That is more or less what drives a factory. And we lined out reference processes. And reference processes are used for us as a North Star. So every factory has now an orientation in which direction they have to develop their processes. And then, last but not least, of course, there is a related IT reference architecture to it. If you would like to scale up, you need a base, you need a platform. And if the platform is not there, of course, you have to introduce in which direction should the investments go so that they can benefit from all the solutions we are developing together. Otherwise, scaling is difficult. Yeah, that is in more or less our way how we are digitalizing our factories from the, let's say, program approach, more or less. And of course, there's always an organization behind, but it's not a line organization, it's not a disciplinary organization, it's a program organization where we are bringing all the experts together from the factories. So what we wanted to reach is that the experts from one plant can identify and talk directly with the expert of an area from another factory. This is why the work streams have responsible persons in each factory. So this gives transparency for exchanging. Sometimes we have small factories out there and sometimes we have big factories, but in small factories there is a single soul working on a technology. He has not the possibility to exchange his experience or his questions with someone else. So here is then the full transparency with which experts he can exchange, and also we are bringing them a regular base together so that they are working and developing together on the solutions. This is a kind of an idea how we are structured and how often we meet. And one of the success factors for us, we met on a plant level each week. So the sprint was always 1 week. Each Friday, 4 or 5 hours, we met and we're looking what is the topics we have to address. So our sprint thinking right from the beginning was 1 week. And that's our working into our general thinking of a digital twin and also a digital factory vision is shown at this picture. So we have our 5 work streams. I come to them right in a moment, what is in there. So you have the digital twin, the processes, which are for us our main working streams, and we have our enabler working streams, so new ways of working, big data analytics, and autonomous manufacturing systems, which are contributing solutions to the vertical and horizontal data integration. And how they are contributing, though the overall digital twin is shown on this picture. Of course, we at Siemens are thinking on 3 digital twins. The digital twin of product goes into the digital twin of production, and then this can be used as a digital twin of performance. And how they are addressing this is shown in this. So this is nothing else than a contribution to the overall idea of getting a holistic digital twin. So, and what is about the roadmap? So a roadmap, of course, is something who gives you an orientation in which direction you should develop one or the other technology, and for orientation, we develop for each of the working groups roadmaps. This is on a very high level, the systematic of a roadmap. You have always a target state on the top, and which is described as a North Star in lean thinking. And then you have evaluation steps towards it. So each factory can orientate where I am and what do I have to develop. And if there is someone else out there who already is developing one evolution step, so can I use them by giving him my requirements, or can I use it so that I can develop it further with my specific requirements? So this gives orientation, and for us also the possibility for visualization where we are in the single factories, from the evaluation state up to the target state. And each evaluation state is also described in content and outcome. And also there are projects dedicated to it. Projects with identified people and project leads. So let's go into a little bit into our working streams. As I said, these are our 5 working streams, 3 enablers, 2 main working streams. Digital twin. So this is the idea, fast and reliable production introduction with simulation based on the digital twin of product and production. So on the processes, it's synchronized planning of all production resources and activities in the supply chain for short lead times and maximum utilization. It's a short form. So you see here the idea of the vertical and horizontal data integration. And then on the enablers, the utilization of deep insights about smart algorithms and artificial intelligence, or the utilization of lightweight robots, we call it smart automation, and of course autonomous mobile robots in this aspect. And new ways of working. Very important for us, it deals about people. People are for us the backbone of each factory, and we have to enable them for that what they are doing now and what they have to do in the future. So as this is a technology journey, also we were always thinking about, I think it's difficult that we introduce technology faster than we are upskilling and reskilling our people, so let's synchronize this. Let's synchronize the up and reskilling of our people with the introduction of the technologies in the factories, so that they can use, of course, immediately the technology which we are bringing to the factories. And this was the aim of the work stream, New Ways of Working. So here you see an example of, as a very high-level roadmap of Lean Digital Factory, and this is digital twin. From the workstream digital twin. You see here, target state, the fully comprehensive and connected digital twin with all necessary information as one line. So this is the digital twin of product, and you see the same as the digital twin of production and the performance. And then when we are looking here on the first evaluation state, then we say, okay, what we want to reach is standardized design with PMI, custom views and enhancing information, based on E-class. And the E-class is an automotive standard for describing the digital twin of product and including design for manufacturing rules and assembly priority graph. So that is what we have to reach there. And 1 and 2, the numbers 1 and 2 are so-called content clusters, which is a number of projects which are led by people in the different plants who are working together to reach this evaluation state. So that you have an idea how this is used for orientation. So, and all of this is of course described a little bit more in detail. So the North Star is here from the digital twin. I will not read it to you because I have videos which are more easy to consume. So, but that you get an idea that it is really described in content and outcome in very, very specific. It is also described what we want to address with it. So if a factory or a factory addresses the workstream digital twin, he can expect that he improves in speed in regards of time to market. This is why it has 3 squares in white. It will increase flexibility 2 out of 3, quality 2 out of 3, efficiency will be addressed 3 out of 3, sustainability in a certain way 1 out of 3, and scalability 2. So it has an orientation. Where is my pain point? What I will get with it on a generic level, but also then later in much detail. And the applied portfolio, you see here, what is necessary to be introduced in a factory to get the full potential out of this is meant here. So what is about the reference processes? A reference process is the full description of introduction of a new product or a new machine, or here it is the new product introduction when the digital twin of products gets, in this example, handed over to production. And the idea is, what can we do fully automated? So how the digital twin has to be described that immediately it can be used for the planning phase, to bringing the production line who wants to produce the product into our factories. This means a digital twin of product needs to know which technologies he needs to be produced. He needs to know even which assets he wants to get used. If we are connecting it to our assets in our factory, the digital twin of product, so immediately if the digital twin of product is handed over to our engineers department of production engineering, so it's like, yeah, the product knows the sequence, the technology, and which assets. And immediately you can have a rough planning of a production line. And we are getting these now in 6 hours. When we hand it over the digital twin of product, we have a rough planning of a production line in 6 hours, due to that it is automated. And then from there, of course, it goes in the detailed planning, and then also in the value stream mapping and in the simulation. And all this is then described in detail if it is automated or if there is manual processes behind. Just an overview how we are mapped it down. So coming to one example. Digital twin is about machines, and we are introducing similar machines in our electronic factories, and therefore we are building, or we have built up a common resource library for our equipment to standardize the equipment on one side, but also to speed up the simulation and the planning tasks. So, and one topic we also addressed, when you go into such simulation tools, sometimes the native data is very, very heavy, and you don't need it because it has a lot of information. So sometimes you just need a model for 3D planning, you just need a simple model for rough layout planning, or you need a 2D layout for maybe some logistics simulation, and all this has to fit together. And this is exactly what we did here. We are building up, and we build up a resource library which allows you to use, always in reference to a native data model, let's say a case-specific reference model for your simulation tasks. So you see it as here on this video. So you have here a common resource library in all factories now, in our electronic factories. And we are able to reuse the work cells we have then developed in one or the other factory. So this saves a lot of time. And as you see here, then it's like building blocks. You're putting them together. Okay, you know now the reference cell, you know which is it. But now for the next step, you don't need the full model. You just need a block model. You bring them into the position, and then later you have everything ready for factory simulation in a fast and very efficient way, and standardized. So coming to the next one, the processes, which is our horizontal data integration. So here we are talking about how do we bring our orders into our factories. There is an order, there is a demand from a customer. How fast can we bring it into the shop floor for production? And this is all about this. We would like to automate. If there is everything clear, if every resource is clear, then maybe there is a way how that is automatically planned, sequenced, and brought into our production and ready for automation if all resources are available. And that's about that what is described here. Okay, this is about speed and efficiency and transparency and tracking of your orders into the factory. So this is described in this case. And of course, we have a reference process too here. So the order comes in. You have to verify if all resources are available, material, people, machines, and support material. If this is the case, why one has to look at it? You just directly bring it into your planning and scheduling tool, you bring it into a sequence, and you execute. And if there is only exceptions, then someone has to look at it. So the main process we always have then more manual is then when it comes to material handling, this depends very strongly on the product by itself. So one tool and what we have developed and gives us very deep insights into our processes is so-called digital value stream. If someone is familiar with Lean and with Lean tools, value stream analysis is a very powerful tool to optimize your process, to bring out the waste out of a process, and to look what is the next best product if you have to organize a changeover on the lines. But also maybe you would like to know when you have a production line where different variants on these production lines are produced, why is one product taking different throughput time than the other, and where do I have to optimize it? And for this, we developed the Lean Digital Value Stream Analysis. And the good thing is now I have brought Christian with me, and he will explain to you how the digital value stream analysis
Hello, ladies and
works.
gentlemen. My name is Christian Jenert, and I would like to give you a quick overview of the Lean Digital Factory Proof of Concept Digital Value Stream Analysis. Let's start with the dashboard. This is the entry point for each user and dynamically shows a value stream based on a set of filtering criteria. Based on the selection, the dashboard shows us the split between utilized resources in a given time frame. With a reselection of the time frame, the shown data gets updated automatically. Besides the resource utilization, we can retrieve further process-related information, like the performance of each product at any given process step. Let's have a detailed look. Here we can view additional information like the performance resulting from the target cycle time, which is retrieved from Siemens Teamcenter, and the actual cycle time, which is being calculated. The changeover matrix shows the actual changeover time between various products. To be able to present valid data, we must have seen at least 5 different changeovers for any given combination. Let's now take a deep dive into the actual cycle time for a single product over the time spent of 1.5 months. From the monthly overview, we can drill down into single days and even hours in which the product has been produced. By zooming in, we get a more detailed view on the data. Let's jump back to the dashboard to have a look at the calculated throughput times for various products. As you can see, the information updates on the change of a filtering criteria. To calculate the throughput time, 2 timestamps are needed. As we only have 1 scanner installed with some of the processes, we don't get a throughput time for every process step. In the throughput monitor, we can view the corresponding time for each product, again do additional filtering, and also select the start and end process step for the recalculation of a throughput time. If needed, one can also view additional statistical parameters like the median, min and max throughput time. Back in the dashboard, we can additionally get information about the current and maximum buffer size in minutes and pieces between decoupled process steps. In the VIP detail monitor, the user has the option to review the buffer development for the pre-selected time frame. This way, the in and outflow of a buffer is visualized. It makes it possible to identify eventual problems. That's it for today. Thank you for tuning in, and we'll talk to you soon.
Thank you, Christian.
Siemens.
So this is a very powerful tool for optimizing production lines because you get really deep insights into your automated lines, and it allows you to optimize it by different variants you are running over these different production lines. So coming to big data and analytics. The workstream is for us an enabler and has different target states and trends which we are covering. It's cloud and edge computing, tracking and tracing, analytic and artificial intelligence. Just also to use these words, it's sometimes good for our management so they know what we're doing. And but we have, of course, our target states, and we're developing it in various factories, by the way. And also we have already smart algorithm and AI based processes up and running. So you see here what we try to reach with this. Of course, quality, efficiency, scalability is the target of big data and analytics. And now also for us, it has the chance to rethink quality management in a complete different way. When we are looking at our quality management, it's always produce, test, produce, test, produce, test. But if we are introducing AI into our processes, it allows us even to define if a product is good even before we test it. So this means we don't have to test it. And this saves really, there's a lot of efficiency with it. If you think on an electronic factory where 40% of the costs are driven by quality assurance. And this is an example which is a combination of quality assurance and predictive maintenance. So what we have to do in electronic factories like in Amberg is we have to cut our printed circuit boards because they are produced on standardized sizes, and then you cut them before you assemble them into the products. And this is one of the process. You can do it by milling, or you can also punch it, but the most of the time we are cutting them by a milling process because it gets less stress on the printed circuit board. But it has one disadvantage. Aggressive milling dust crawls up the spindle out from the PCB, and then the milling spindle gets stuck. And then you have an unpredicted downtime, which you don't want in a high volume production. So what we are developed was an algorithm which has a combination of currency and speed of the motor of the spindle with anomaly detection, and that allowed us to identify a pattern 2 days in advance before a milling spindle breaks down. And this is for us enough time to plan the downtime, which is a big advantage because you do not have the people on the line. You can just plan it, and it doesn't have an impact your output, or you do it even on a shift where no production is planned. And this is already developed to more than 18 machines, and now we are going it to the other factories. We have it now in Germany. We're bringing it out to the other factories in China because it has so much advantage for us. So another use case is now explained by Jochen, where we were deploying an algorithm also for the it is a vacuum gripper, and the vacuum gripper have the problem also that the cartonnage in a packing machine is not clean when we get it. They don't clean it, so there's always small dust on it. So when the gripper are working, once in a while the dust gets stuck in the vacuum gripper, and we have unplanned downtime, and Jochen explained what we did here.
Warm welcome from Hamburg. I'm standing directly in front of the ET200SP-F assembly line, respectively the packaging machine. Inside this machine we have a Schmalz gripping system, and this gripping system is used to feed the packaging machine with the cardboard boxes. The challenge in this process is that the gripping system loses suction power due to the existing fine dust of the cardboard boxes, and this results in unplanned downtime. To solve this problem, we decided to work together with Schmalz and on the basis of our industrial edge ecosystem. Schmalz developed their application on basis of the Schmalz Connect suite as part of their digital offering strategy to serve their customers even better. The app is developed on Docker Compose and deployed directly to our industrial edge device. During operation, the edge device is collecting process parameters like suction pressure and air compulsion rate to really predict the unplanned downtime, and we have the possibility to replace the unplanned downtime by a planned downtime and have at the end a higher output of the production line. Speaking for Schmalz, Schmalz is motivated not only to serve Siemens, respectively Amberg, with this solution, but also for their customers globally. And to achieve this goal, we work closely together to bring the solution to our industrial edge marketplace, that every participant has the possibility to download the application, deploy the application in their shop floor, and generate value. To sum it up, in the future it is really important to think and act in ecosystems. And the industrial edge ecosystem plays a major role in the digital transformation of the future. Thank you very much.
Good. So this is 2 examples how we are attacking unplanned downtime with predictive and prescriptive maintenance. So coming now to the next topic, our autonomous manufacturing systems. And here, of course, we were lining out a roadmap, as I have described it before. It has everything to do with robotic here, everything with robotic, with automation, and with autonomous mobile robots and a combination out of it. And we have a roadmap how we are using this. Of course, all these working groups are interlinked. As you have seen in the example with Jochen, there were robotic in the background. So this is always, of course, a close collaboration between the groups. That's for sure. But here we are talking about how we are able to use robotic to be more efficient and to automate even more processes. So let's look what we have there reached so far. And the autonomous mobile for intralogistic is very interesting for us in our factories because manual transportation is an issue in many factories. And if you look wherever you go, there is still manual transportation. Even a person brings something to a place, or there is the forklifters, or there is a lot of autonomous transportation to bridge the gaps of the material, raw material, and the production location. And here is an example where we are replenishing empty boxes. We need empty boxes for our finished products in our production lines back to the production line. So when we look at this, there is a kind of a robotic cell in our basement with an UR robot who is continuously bringing empty boxes on the conveyor so that these empty boxes going back to the production lines so that the machines there or the workers can sort the products into it. So when there is a request, this robot is automatically replenishing the box to the conveyor line. But what is it doing when the place is empty? There is no box anymore. So the robotic is then asking for support by another robot, the autonomous mobile robot. He really is calling him wherever he is. He goes down then with the elevator and is bringing out the pallet from the robot cell, and he's bringing new empty boxes into the robot cell, completely autonomous. How does he know that there were and which place the empty boxes were standing? When he is passing by picking up the empty pallet, he's scanning the location and already looking which place I have to take out my empty boxes to bring it into the robotic cell. And when he was finished, he confirms it so that the UR robot can continue his work. Now, he then starts and can feed back the empty boxes, completely autonomous. So the next big thing is always handling chaotic supplies. So sort them is an option, but it takes effort. People have to sort them, or you supply directly out of the box. And here you always have an issue to identify the parts. And for this, optical visualization support in combination with robotic gives us the opportunity that we are bringing completely unsorted material to the line, and then the roboter are identifying which parts and sorting them out and brings them then sorted to the line back. So, new ways of working. You saw Chanel in the first video. She was talking lifelong learning is our journey, but also it is very important that we were not introducing technology on a faster pace than the people were reskilled and upskilled or introduced to this technology. So this was the task of this working stream. And literally spoken, what they did is they scanned all job profiles and looked them how they will change over time. What will be different in these job profiles over the time while we are introducing new technologies, and then derived a learning program from this. So if there is really a complete reskilling or an upskilling necessary, there is then dedicated learning programs for the dedicated job profiles. So when there is a skilled shop floor employee and we know what is his job file in detail, we have a learning path which brings him then to the position that he will be able to fulfill also his job in the future. And this has brought very, very high acceptance of our people on the shop floor by introducing digitalization. Sometimes we hear that there is resistance by bringing digitalization, new technologies on the shop floor, but we can say while we were taking and introducing also the re- and upskilling program with a dedicated learning journey to our people based on their individual job profile, we received very, very high acceptance and involvement of our people. So, finishing up, what is the next challenge now? And this is also my introduction to and bridge to that what comes later also. But we are also working on this. What is the next challenge? What is it? The carbon footprint. Of course, sustainability was in our roadmap at the beginning. Carbon footprint of our production is the next big challenge. And in the program of our Lean Digital Factory, our factories need to be carbon neutral. Of course, we can tackle scope 1 and 2 very easy. We can buy renewable energies. We can track via the digital value stream very in detail on which machine we are using which energy and calculating the carbon footprint dedicated to the product, to the variant, to the very product down. But we know that 90 to 70% of the product carbon footprint lies in the supply chain, and here we need a solution. And so we are working on a solution which is called SeaGreen, where we are enabling the exchange of the carbon footprint on scope 3 between suppliers and customers. And we're bringing certifiers in it so that we can trust this information on a very high level. And also we are bringing carbon sinks into this network. The best thing is that I have a last video, and I think I have time, 2 minutes, that you get an idea what we are working on here. So let me summarize what you saw just here. When you are a manager of a product and you want to manage your product carbon footprint, you have the possibility to load up your bill of material into the program, and then you can ask your suppliers that they will provide their product carbon footprint of the module they are providing with you. For this is not standardized. But here, the methodology has the possibility that you standardize the methodology how you calculate, if it is on greenhouse gas standard or on ISO, and you know exactly what is in and what is not in. And as the direct exchange is via your supplier relationship, peer-to-peer, you can ask for certification on a company, which is a certifier and has the knowledge about how the supplier is producing and the way he is getting together the data about a certification. And the certification is exchanged via verifiable credentials. So he requests the certification, and so the supplier is able to present the data of the product carbon footprint to you as the customer with a verifiable credential. And you, as I am the customer, I can now go out to the certifier and ask for verifying this verifiable credential, so I know it's true, as you did it when you came in with your COVID pass. So this means no data has to be shared which are confidential. Your data stay in the data sovereignty completely. It's trustworthy and very efficient because you can ask it through the whole supply chain down to the mining or to raw material. And for this, we are going to donate this tech stack into an association so that the whole industry is able to use it and can build their own connector to it. And we worked it out. The idea was born in the World Economic Forum together with Dimitri. And now we invested it, we developed it as a product, and we'll give it into an association that the industry can share it, because it's the only way I've seen so far where exchange is possible without bringing everything up to a central platform. It's a decentralized ledger technology where all the control of the data stays with the issuer of the data. So that's for it. I hope it was not too much and not too it was short while. So thank you for your attention, and I'm here for further questions. Thank you.
Thank you very much, Gunter. So we have time for questions. If there are any questions in the audience, please. There's a microphone coming around.
Hi. A lot of the examples you showed seem to be bottom-up type of improvements, sort of iterative. Are you also thinking of a more fundamental top-down sort of complete reinvention of the factories?
So the Lean Digital Factory program started as a bottom-up approach, completely right, as you see it, because the idea is always to solve the problem on the lowest organizational level as possible and enabling the people. But there are topics which we are now driving as more from a company or let's say overall level, but they came also up. There are three main topics. It's the introducing a manufacturing data platform, which is an important topic because it goes about reinventing the IT reference architecture in our factories. So this cannot be done top-down. So here, yes, we are reinventing in a certain way. We have defined a new IT reference architecture for our factories, which allows them to connect directly to the different levels and up to the cloud if it's needed. And then we have an initiative where we are reinventing the manufacturing execution system. As we see them today, we introduce monolithic manufacturing execution system in our factories, and I mean not our factories, I mean general all factories. And in the most of the cases, the functionalities are not needed in smaller and medium-sized factories. They are built for big plants based on standardization, like we see it from the big automotive OEMs. So we are building at the moment modular and manufacturing execution systems, which is based on microservices, so that you can, like your telephone, that you can choose the functionality you want. And third, we are developing master controllers for micrologistic, because we see so much different robotic systems out there, but you have to run every of these robotics, AMR, on a different master controller, so we are bringing them together on a platform, and this is also a common and a joint effort. So when from these three topics, yes, we are completely reinventing and restructuring the factories in regards of IT architecture and the aspect that OT and IT comes here much closer together. It was not the focus here because it was more that. Yeah.
Gunter, thank you very much for coming here and for your talk. I have one question for you. So in one of the last brochures of Siemens about Internet of Things that I saw a couple of weeks ago, so they are talking about asset performance, predictive maintenance that you mentioned also. And at the end, there is the term closed loop digital twin. Can you tell us, please, a little bit about this?
So the closed loop is everything feeds back to engineering for us. That's what you see here. Everything goes backwards into the digital twin of the product, into the engineering part for further optimization. Even the carbon footprint, when we are talking about CO2 footprint, we are feeding this information from real data back to the digital twin of the product, so that we can see that what was estimated upfront from the beginning is complying with the reality and what we have to change there. If we are talking about digital twin product, production and performance, always the performance are feeding backwards into production and into the product for further optimization in regards of the product and our equipment. And this is what we always are trying to close.
Thank you very much for your presentation. In the semiconductors industry, they use RAM for reliability, availability, and maintainability. Those are normalized or standardized criteria for downtime, unscheduled downtime, and so on. Would you have some data or information? What is the improvement or how those RAM parameters are improved going when you implement your LDF, your solution, as it is improving those KPIs?
It varies. I mean, we are measuring mean time between failure and mean time between repair in our different factories. So it varies very much in our factories what is the improvement. And I do not have a number now which for average. So this is something we are establishing, one measurement in this, and then from there we are trying to improve. So on this level, I do not have any average or number. What we see is that we are improving our factories with the program by itself. So we were coming from 3 to 5, and now we are in average over all factories between 5 and 7% of productivity. That is what we are really measuring on an overall scale. So operative-wise, it's difficult. No, I do not have a number. But because also I think I don't know if we can compare it with semiconductor. Just when we go to mobility, when we are going on trains, totally different when we go into high volume. So only thing what I can say, we measure it and we track it, but a number. Maybe another comparison is over the last 4 years in our electronic factories, we were able to increase our volume by 130% without any additional headcount. I mean, that's so much, 140%. Output improvement over 4 years without increased. This is the automation and digitalization level we reached.
Very interesting. Maybe we take 2 more questions. remember, we have the panel this afternoon, so any questions not replied to this morning, we can take up this afternoon again.
Good morning. Thank you for the presentation. Two questions. On the SciEnergy part and from a circular economy perspective, carbon footprint is important for the community of players that are acquiring the products. Do you have more variables there, like provenience of materials, batteries, other elements that are important from a supply chain perspective and that companies now want more just besides carbon footprint? And then finally, your last phrase was that you apply the decentralized ledger technology on the whole platform. Can you tell me a bit more about that? Which type of technology and what's the use case? Thank you.
So what we are doing at Siemens is, of course, we take our products back and feed them back into, if we have the chance to change over products, if someone wants an upgrade, so we take our products out and of course then we are feeding them back into the recycling circle. But at the moment, the carbon emission are the most pressing topic, and this is what we are tracking. We believe that there will come up more ESG measurement, especially when it comes to forced and child labor. That's an issue what we see, and we also have it contractual. Of course, fair payment in all our suppliers. That is what we have at the moment contractual. And clean oceans and all these topics or deforestation, we believe that it will come and will be not only, it is not enough to do it contractual. I think we have to track it and trace it really. So at the moment, the carbon emission is the only detailed topic we are now bringing into the industry, but the systematic behind of it, and now coming to the other question, can be used for all other ESG measures also. It does not have to stop with carbon emission. The idea is that I use my peer-to-peer supplier customer relation for direct data exchange by giving a general user interface which is able to ask and request directly, and then via a third-party certifier which is verifying the data, we believe is a very trustful and powerful way for all ESG data you want to track. And the distributed ledger technology is for us the only way, because honestly we don't believe that all the models where you load up any data on a centralized data platform, I think it's over. That nobody wants this anymore. Nobody really wants it. There must be a benefit really if you do it, and it must be trustful. But why should you do it if there is another way? And the distributed ledger technology is a way where you can keep your data on premises under full control. You have the data sovereignty, and you have the control even to revoke the data you have shared. And no other technology can give this if it is centralized. And this is why we believe that such ecosystems must be built on decentralized ledger technologies.
Thank you. Maybe one last question.
Thank you for your presentation that clearly described the path that you have in mind for deploying the Lean Digital Factory. There is one point in there related to the Schmalz example that you've mentioned, which goes a bit beyond which, because for your internal processes, you are fully in control. As soon as you target suppliers, you will have to integrate in the system something that is more in the ecosystem, that is not fully under your control. What is your view on how to create standards or shared models for the APIs and the data models that will be required for feeding your digital twins with information coming from suppliers?
We are motivating our suppliers, of course, that they are providing the simulation and the information in a format we are able to integrate in our digital twin. But as you say, it's just a motivating topic, and we are working on normation and standardization in the association, but we will not force our suppliers to use a standard. It's more that we are looking a way how can we integrate the different standards and work with them. Standardization takes too much time, and there's always two ways, I believe. You can standardize the world, but then takes 100 years, or you try to organize the different formats and try to integrate them. For this, you need then smart algorithm or AI. And at the moment, of course, both ways is good to tackle, but we are more integrating and instead of pushing a standard. That's clear because Siemens has always the both roles, customer and supplier. We are in between. So we are not an OEM, which is on the end of the food chain, so where you can say you do it this way or you are out. We want and we need to work with both sides.
Thank you very much. Let's thank again Gunter for his talk. We now have a small break. You can have a coffee and a croissant. Please take the advantage also to talk with people in front of the poster if they're around. And please be back seated at 11 for the talk of Georg Fischer.